All right, guys. Hey, welcome back. Okay, and actually, I'll stop right now. There we go. Okay. Hey, welcome back to another lesson. Today, we're going to talk about angles of elevation depression. This video is going to be formatted a little bit differently. I'm going to have the PowerPoint up here because I had to draw the pictures for you, and then, excuse me, and then I'm going to solve the actual problem on the whiteboard behind me. Okay, if that makes sense. So let's just jump into it. All right, and here we go. Boom. Okay. So angles of elevation depression. So when we talk about an angle of elevation, okay, looking at this, we're talking about just from a person's perspective. Okay. So looking at this, I have my person right here. Okay. And if I look straight ahead, that's his dotted line, that's his horizontal line. Now let's say there's some object up here that he's looking at. Okay. So as he's raising his head upward, he's creating this angle of elevation. Elevation meaning that you're going up. Okay. So that's what we're going to be working with today. We're going to do some trig problems where there has some angle of elevation involved and angle of depression, which we'll look a little bit later. Okay. We're going to solve two problems of each. So here we go. All right. So here's the first problem. Okay. And I'm going to try my best to draw this on here. Mary wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Mary is 5.5 feet tall, how far is she from the castle to the nearest foot? Okay. If you like to draw, then this is your lesson. So here's Mary. All right. There she is. Happy to be in the amusement park. Boom, boom. And we'll put her eyes here. There we go. With a smile. All right. Over here, I got my castle. Okay. And what we're going to do is we're going to read this word for word here, just like a translation type deal. So Mary, if she looks straight ahead, okay, she could see the castle. And if she tilts her head upward, she could see the very top of the castle, right? And this angle right here is going to be 38 degrees. Okay, so let me just type that in here. So this is going to be 38 degrees. Okay. All right. Now let's continue with the other stuff. The castle is 190 feet tall. So from here to here, okay, this entire distance, boom and boom, all right, is 190 feet tall. And they also tell me that Mary herself, from here to here, Mary is going to be 5.5 feet tall. Okay. And what we want to do is we want to find how far is Mary from the castle to the nearest foot. So that's going to be the bottom, the x value. Now notice her horizontal line of sight is going to be perpendicular to the height of the castle there. Okay, so there's a right angle involved. We have a right triangle. Okay, considering that we're talking about trigonometry, we know there's a right triangle that's going to be involved. Now let's go ahead and figure out another measurement because we're going to need this. This is x right here, but notice something. If I want to figure out, and let me just do a different color here. If I want to figure out this side length right here, because I'm going to need that side length, right? It's not 190 feet tall. Okay, in fact, if I take Mary's height in consideration, I could just move this all the way over here. You see how from here to here, that would be 5.5 feet? Now, this isn't drawn to scale, obviously. So if I want to figure out this guy, I would do 190 minus 5.5. Okay, so when I do that, I get 184.5 feet. So that's going to be this side length here. Okay, what do you think? So far, so good. Now let's go ahead and label the side lengths. So starting from this angle here, this side length, the 184.5, is the opposite side, and the x value is the adjacent. Okay. Now, if we go back to SOHCAHTOA, tangent is the trig ratio that deals with opposite and adjacent. Okay. So we're going to have tangent. See if I could write that. There we go. For this guy. Okay. So that's the setup there. So let's go ahead. I'm going to switch it over. Stop sharing the screen here. Hey, how's it going? All right. Let me go ahead. I'm going to write this on the board so you guys can see. Okay. We're going to bring the problem to life. This over here. So we're going to have tangent. Okay. The angle is 38 degrees. And that's going to equal to 184.5 over x. Okay. And I apologize. That is very light. Let me use a different color here. That way you can see it a little bit better. Okay. Now to solve this, we'll put this over 1. We'll cross multiply. So this would be x times tangent of 38 degrees. And on the other side, 1 times 184.5 is still 184.5. To get x by itself, we're going to divide by tangent of 38 degrees. That would cancel out with this guy, right? And on the other side, I'm going to have to do division. So 184.5 divided by tangent of 38, you get 236.1 feet. The problem does ask right to the nearest foot, so we would say roughly 236 feet for that guy. Okay? That's how far Mary is from the actual place. Not too bad, huh? It's just the setup. That's the new part for us. And using the word angle of elevation, that wordage is what we got to get used to. But this part we've done so much of, this is actually pretty routine now for us. Okay? Let's do one more problem. Okay, I'm going to go back to the PowerPoint here. Okay, there we go. So let's go ahead and look at second example. Now remember, I have more examples in here. The notes are uploaded. Be more than happy to explain more. If you need it, just contact me. Okay. All right, let's talk about football here and not soccer. All right, the other football. The crossbar of a goalpost is 10 feet high. If a field goal attempt is made 25 yards from the base of the goalpost that clears the goal by 1 foot, what's the smallest angle of elevation at which the ball could be kicked? All right. I know there's a goalpost. I'm going to draw one. All right. So let's draw a nice little goalpost. Boom, right there. From the goalpost to the bottom, they tell us that's going to be what, 10 feet? Okay. That's this part of the problem. Okay, over here is my football. I'm gonna try my best. There we go, there's my football. And it's 25 yards. Okay, 25, yards. I gotta come up with an easier way to do this. From the base of the goalpost. All right, now, if we look at the next part of the thing. Oh, that was bad. I didn't mean to draw all over that. From the base of the goalpost, the football clears it by 1 foot. All right. So here's my football. It's going to come all the way up here. Okay. And the height from there to there. So from this point to this point, we have another foot. I'm going to put a 1 there. Okay. And obviously the height is perpendicular to the ground there. So they want to know what is the angle that the ball was kicked to get to that point. Okay, well, we can do this. I'm going to introduce a new symbol there, Greek letter. Okay, that is theta. Doesn't look like theta. Ooh, sorry. Let me change that. It's a circle. There we go. Now see, that looks a lot nicer when I do that. Okay, so there we go. We're going to use that guy right there. Okay. So I'm going to draw theta right here to represent that angle. It's very common to use that when it comes to trigonometry. Since this isn't a trig course, I won't go too far into it. So that's just called, let me write that down for you guys, theta. Now I could have put in angle A, angle B, but I'm going to give you a new term to kind of look at and play around with. All right, so I'm going to find the angle. There's an issue. There's a problem. Do you see the problem? This is in yards, the height's in feet. We're going to do a little bit of a conversion. Remember, 1 yard is 3 feet. So to convert 25 yards to feet, I got to multiply it by 3. So I got to times this by 3. Okay. And we would get, what, 75 feet? Okay, just like that. Perfect. Okay. Now that's the measurement I'm going to use. So just be cautious. When you're setting up these problems, make sure that there's no unit conversions that you have to do. And if you do have to, do that before you start calculating with trig. All right. Now, I can see that here's theta right there. Okay. 75 feet is the adjacent side to this guy. Now, over here, what's the total length? Let me use a different color for this. What's the total length of this guy here? Well, it's the 10 plus the 1, so that's what, 11 feet. And that side is opposite to this angle. Opposite and adjacent, uh-oh, we got tangent again. Can I write it? I think I can. There we go, tangent. So we're gonna use tangent to find this angle. Okay, so let's go ahead. Let me just erase the previous work that we did. It's not always going to be tangent, just FYI. It just kind of worked out that way, huh? Tangent of theta equals 11 over 75. Okay? Now remember, to figure out the angle, we have to use the inverse. And that was the previous lesson. We talked about that. Take the inverse of tangent, and we can figure out what theta is, our angle. Okay? Now when you do that, you get roughly 8.3 degrees. And I want you to take it to the whole degree, nearest whole degree. 8 degrees would be for that. So the ball had to be kicked 8 degrees to clear that goalpost by a foot. Okay? Alrighty. Kind of see where this is like culminating the first 3 lessons into one, right? You have to figure out what the trig ratio name is. You have to figure out the side lengths that go with that trig ratio. You got to set up the problem. You got to use an inverse to find the angle. So everything's coming together here. Okay? All right. Now, that's angle of elevation. All right, let's look at angle of depression. It's a little bit different. Okay? Now, here's the cool part. In fact, I'll tell you what, let me stop sharing the screen real quick. I'm going to show you how angle of depression doesn't have much difference to it. Okay? So as you can guess, if I want to make this my eyeball, okay, let's say, well, we'll say this person's really high up. Okay, there's the smile, looking at it from the side. If it's looking horizontally outward and then moves downward with its eyesight, okay, this would be your angle of depression. Okay. Now here's the deal. Okay, you can draw the triangle from here. You can put your height there, and there's your base and solving it. But I want you to take a look at something. The horizontal line, that is the eyesight that you start with, is going to be parallel to the ground. Okay, no matter what. Which means if I take the height from where the person is to the ground here, I have a right triangle that I can form. Now you're probably saying, wait a minute, Mr. McCullough, but the angle's still out on the outside of this triangle. For now, these guys are parallel lines, right? Let's go back to this for a second. Okay. This line is my transversal. These guys right here and here are alternate interior angles. What's this? Okay. So if this is like a 40-degree angle depression, this guy is a 40-degree angle depression. Okay. By alternate interior angles, using the principle that the ground is going to be parallel to your eye level when you're looking straight out. And it is. Okay, there are parallel lines. They're both horizontal trajectories there. Okay. Does that make sense? So realistically, an angle depression problem is really not much different than an angle of elevation problem. Okay. All right. Now let's jump into an example and see how this works. Okay. So here we go. All right. So that's what this is showing you here. All right. So let's do 2 of these guys. Where is my? There's my drawing pen. A search and rescue team is airlifting people from the scene of a boating accident when they observe a person in need of help. If the angle of depression to the other person is 42 degrees, The helicopter's 18 feet above water. What is the horizontal distance to the rescuers to the person to the nearest foot? Now, obviously, we're taking a lot of assumptions into case. We're going to keep this very basic. We're not going to put some physics and, technically it's this, this, this. No, we're going to keep it very straightforward. So here's my helicopter up here. Boom, we'll put an H. Yeah, I'll tell you what, we'll make it, there we go. There's the helicopter. We'll make it really look official. There we go. Okay, so there's my helicopter. And then down here is my person that I got to rescue. Okay. All right. Now, the helicopter itself is 18 feet above the water. Okay. Now, the horizontal depression, if I look straight out and then look down to this person, this right here is 42 degrees. Okay. And I want to know what the distance is from the swimmer to the helicopter. Okay. The horizontal distance. So this is a right angle, right? Perpendicular to the ground or perpendicular to the water, the height for that. Now remember, the horizontal line of the pilot or the helicopter, if you're looking at it from that perspective, is parallel to the water, okay? So if that's the case, this guy must be 42 degrees here. It almost looks like an angle of elevation problem, right? Okay, so now looking at what we have here, we're gonna go ahead and I'm going to erase this top line for a quick second. Let me just erase this. And here's my triangle. That's what I'm going to be dealing with, okay? Now let me just put that back real quick. So when it comes to angle of depression elevation, not much of a difference that you have to worry about when it comes to it, okay? But I would, just for my future reference, so you know that that's what's happening, draw that it's alternate angles, and that's what's happening. All right, now we're just going to go ahead, label the side lengths. And let me go back to erasing that there. We don't need it. So from the angle that's 42, this is the opposite side. X is adjacent. Oh man, this is another tangent problem. I put a lot of tangents in here, huh? I mean, a lot of it will be, would you have to find the hypotenuse at any point? Absolutely. And you'll see that in the homework too. So we're going to use a tangent to figure this out. Okay. So tangent of 42 degrees equals 18 over X. Okay. So let's bring this back here. All right, let me erase this guy. All right, so tangent, 48 degrees, right, equals 18 over X is what we have there. All right, cross multiply to solve it. So 1 times 18, 1 times 18 is 18. X times tangent of 48 will be on the other side. Okay. X is by itself, last step. Divide both sides by tangent of 48. That means in your calculator, you would type in 18 divided by tangent of 48. And if we round to the nearest foot, we'd get roughly 20 feet for that guy. Okay. Pretty useful tool, huh? Just knowing from a perspective what your angle of just vision from an object to a person, we can calculate quite a bit here because remember, we can create a right triangle with those measurements. All right, what do you think? Want to try one more? One more, just so you kind of get the gist of it. I apologize if this video is a little bit longer. I'm sorry. Okay, let's try this one here. Wrap it up. So a lifeguard is watching a beach from a line of sight 6 feet above the ground. She sees a swimmer at an angle of depression of 8 degrees. Okay, how far from the tower is the swimmer? Okay, so we're gonna neglect the height of the lifeguard for right now. Okay, we're gonna make this, like I said, very basic. So here's the platform that the lifeguard's sitting at. That's 6 feet. Here's the swimmer out in the water. Another swimmer, here we go. You know what, this is This isn't too bad, me drawing this, okay? All right, so we're saying that here's my line of sight. And then if I look down at where the swimmer is, that angle is 8 degrees. Boom. Okay. So let me draw the rest of the right triangle here. So here's my right angle. Okay. And I know because the line of sight is parallel with the ground that this is also 8 degrees because they're all two interior angles. Okay. And then I want to figure out how far from the tower is the swimmer. So it's going to be down here at the bottom. So that's going to be X there. Okay. Now, this is very, very similar to what we just solved, but I want you to get used to the setup and how this looks like when you draw it. Because when you get to situations where the problem is throwing more information at you, it could be a little bit tricky. So it's good to draw a picture like this. Okay. Now, I'm going to go ahead and erase the top. We don't need that anymore. Okay. And then if we could take a look, it is the same as the previous problem. That's my opposite side. This is my adjacent side. So once again, we're going to use tangent. Ah, that's a big T there. Sorry. We're going to use tangent for this problem. So it's going to be tangent of 6 over x. Okay. So let me just go ahead and just bring it back to the whiteboard. Let me erase this guy. All right, so here we go. We're gonna have tangent of 8 degrees equals 6 over x, okay? And as you can see, all right, I'm gonna have to go through the same process, cross multiply, just like the previous values or the previous examples. So we have 1 times 6 is 6. The other side would be x times tangent of 8 degrees. Divide both sides by tangent of 8 degrees. Okay, and this is where your calculator does the other part of the lifting, right? It does everything else for you. So 6 divided by tangent of 8 degrees will give you roughly 43 feet. That's how far the swimmer is from the lifeguard tower. Okay, so I know it's a little weird because we're saying that the lifeguard tower, from that perspective, the angle of depression is like that. But like I said, we're just going to keep it very clean and neat just to practice setting these problems up. Okay, and that's it, guys. That's the lesson. I have other examples online. You can be more than happy to look at them and try them out for yourself. But I hope you are all doing well. And until next time, I will see you in the next lesson video. Take care, guys.